Hello everyone, I'm Axay, a software engineer at Chainsafe, and we are building Go Summer, which is a Polkadot host implementation in Go. Recently, I have been focused on uh, Parachain support in Polkadot host, and this Parachain has been grouped into multiple subsystems, and one of the subsystems is baking subsystem, and currently I'm working on this baking subsystem. And while working on this baking subsystem, I came across this wonderful topic called Erasure Coding, and today I'll talk on Erasure Coding. I promise you guys that by end of this presentation, you all will have a wonderful understanding of what Erasure Coding is and how we use Erasure Coding in Polkadot. So let's find out what Erasure Coding is. Suppose if you have a crucial data and that you cannot absolutely cannot lose that data. One way is you can make identical copy of that your crucial data and store them across various devices and different locations. This is safe, but it's redundant and need lots of space in memory. Here comes a game changer in the world, in the field of data protection and redundancy, the erasure coding. In erasure coding involves divide the data into fragments, add the magic of redundancy, and distribute those fragments across devices, or in our case nodes, and result a wonderful encoded fragments in which does not carry only original data but also carries redundant fragments, using which you can regenerate original data even if we lose some of those encoded fragments. Okay, so let's find out how erasure coding actually works. If we have some important data and we have 6 storage devices, and if we want to store redundant information in 2 of them, erasure coding will create a total 6 fragments of that data, out of which 2 will be redundant information and 4 will be original data fragments. This redundant information also known as parity, and that's what allow erasure coding to reconstruct original data. As you can see in this slide, if we lose number 2 fragment and number 5 fragment, still we are able to reconstruct our original data using erasure coded chunks. Let's see what are some advantages of using erasure coding. So erasure coding improves durability, as anytime we can reconstruct the original data. It also enhances availability by simultaneously allowing those fragments to access, and it also reduce cost of memory space, as we don't need to now store redundant entire copy of data in devices, hence it will not need more space. There are also some trade-offs to consider. Uh, Erasure coding involves additional computational overhead for encoding and decoding the data, which can impact the system performance. Additionally, the process of reconstructing the data may be slower because of this additional computational overhead of encoding and decoding the data. Now let's see where we actually use this erasure coding in Polkadot. So in Polkadot, uh, 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 some validators are assigned to a particular parachain by a parachain assignment routine, and these validators are called parachain validators. This parachain validator will establish a connection with collator. Collator is nothing but a full node of a particular parachain, which will propose unsealed parachain block along with proof of validity. For Polkadot to scale for thousands of parachain, a proof of validity needs to be represented in something smaller in size, and that's why this parachain validator will create candidate receipt of that parachain block. Before sending this candidate receipt to the other validators on a relay chain, this parachain validator who created candidate receipt must also perform erasure coding and generate erasure coded chunks to send those chunks and candidate receipt to its corresponding validators on the relay chain. And then whichever this validators receive a chunk and a candidate receipt will send those two data to relay chain transaction queue, and then author can add it to the block. So in parachain, erasure coding performs this way. It will have a data which is a parachain block plus proof of validity. It will generate 6 fragments here, as we have total 6 validators. Sorry for the mistake, I have wrote parachain validator. It's not parachain validators, it's relay chain validators. Sorry for this mistake. Erasure coding will generate the total 6 number of fragments, because we have total 6 validators. And even if there is a formula to find out how many chunks we will require to regenerate our original data or original message. So this is the formula mentioned. This is the same formula used Polkadot to calculate the number of chunks will require to reconstruct the original data. And if we have 6 validators, we will need only 2 validators available to provide the chunks. And if we get these 2 fragments of erasure coded chunks, we will be able to regenerate the original data, which is parachain block and proof of validity. In Polkadot, erasure codes are used to keep parachain state available to the system without without keeping tabs on all the parachains. And at the end, this Polkadot use their own implementation for erasure coding, which is a novel polynomial, basis, and it performs encoding in order of n log k and decoding in n log n finite field operations, where this n is a total number of chunks we create using erasure coding, and k is a number of chunks required to regenerate the original data. And if you guys are curious to know about this implementation of Reed Solomon Novel Poly, you can visit this link provided on the slide. There you can find the research paper on this basis, and you can see the implementation also. Yeah, that's it. Any questions?
Yeah.
Are the Erasure coded chunks distributed to all relay chain validators or only to the ones assigned to that parachain?
All the relay chain validators.
All the relay chain.
Yeah.
Thanks.
Yeah, is there a second question from the audience? It's time. Okay.
No one? Okay. So we are hiring at Chainsafe. Please visit career page of our website. Also, feel free to visit and contribute to this amazing project called Go Summer, which is a Polkadot host implementation in Go. Also, let's keep in touch. These are my social handles. Peace. Sorry?
Is Go Summer production ready?
No, we are building it.
Okay. Thank you, Axay, for this excellent presentation.